Buonasera e benvenuti a tutti. Questo convegno di oggi pomeriggio su un tema che sta molto caro ultimamente, no? Quello dell'agricoltura 4.0, se ne parla tanto qua in fiera. Il convegno di oggi sarà in lingua inglese, a parte questa breve introduzione, quindi poi switcheremo lingua strada facendo. Volevo solo raccontarvi un'idea, diciamo così, alla base di questo convegno, che è quella di andare a vedere il concetto dell'agricoltura 4.0 da un punto di vista della standardizzazione e dell'interoperabilità. Abbiamo visto tante soluzioni, ne vedete tante qua in fiera, tante ne stanno nascendo, tanti costruttori propongono soluzioni per l'agricoltura 4.0 e spesso queste soluzioni non si parlano tra di loro, ma bisogna partire ancora più indietro, bisogna partire dalle basi come quelle della comunicazione tra le macchine, tra trattrici e attrezzature, per le quali abbiamo già uno standard di fatto che è la tecnologia ISO-BUS, no? Quindi cerchiamo oggi di andare a vedere cosa è stato fatto, diciamo così, nel recente passato, cosa c'è ora di disponibile sul mercato, cosa sta facendo AEF, Agricultural Industry Electronic Foundation, per promuovere il concetto di standardizzazione e di interoperabilità dei dati e soluzioni in agricoltura e quali sono poi i prossimi passi tecnologici. Prima di partire vi porto i saluti del presidente di Federunacom Alessandro Malavolti, che purtroppo all'ultimo secondo non è riuscito a venire, bloccato in un'altra riunione. Abbiamo come Federunacom una collaborazione con AEF che nasce, diciamo, si concretizza nel 2013, siamo diventati membri, terza associazione, membro del comitato direttivo dell'AEF. Continuiamo a promuovere le attività nelle quali crediamo appunto nello standardizzare, nell'offrire agli agricoltori, alle aziende agricole delle soluzioni che possano parlare tra di loro, anche se provenienti da differenti costruttori. Quindi grazie per essere venuti, non rubo ulteriore tempo, switch to English. I give you the speech to Marco, the speech for the first part, and then to Andrew Oliver.
Yes, thanks, Alessio, for the warm introduction. My Italian is not too good, to be honest, but I'm sure it was warm. Yeah, well, let me first introduce myself. My name is Marco Brück. I'm a direct employee of the AEF, one of 6 direct employees. And within AEF, I'm responsible for the coordination of the conformance test development. Yeah, that is what my daily job is about. And yeah, today, Andrew and me, we would like to introduce the interoperability and standardization in AG 4.0. And yeah, this is basically what our agenda is about. I will first say some introductive words regarding the AEF in general. I will talk about a general concept for ISO-BUS, about server-client communication. I will proceed then with TCGeo and FMIS as a perfect couple for precision farming. And I will go on with TIM and the cross-brand closed loop in field communication. Afterwards, I will focus on the ISO-BUS conformance tests. Unfortunately, Simone Zamboni, the test laboratory engineer for ISO-BUS certification, he's not able to attend today, so I will take over this part of the presentation as well. And yeah, the last 2 points are then our updated AEF database and yeah, our approach for a virtual Plugfest in COVID times. And then I will hand over to Andrew Oliver to talk about our new AG-IN project, as well as the status of the wireless in-field communication. So first, agenda topic is the introduction of AEF. Well, I will introduce the AEF very roughly because I imagine that most of you heard about it and followed a few news and presentations yet. The AEF was founded in 2008 by 7 agricultural machinery manufacturers and 2 associations. And in the meanwhile, yeah, many companies, associations, and organizations joined us. So we have today around 250 members. And what are we doing? Well, we would like to increase and improve the image of the isobus technology worldwide. We would like to, in some, reduce the standalone solutions which are outside, and we would like to improve the isobus in regarding new functionalities for which isobus can be used in the future. Regarding our services, I listed here a few. First, it's the AEF isobus database, which we are using to ensure that the certified products and the isobus certified products can be listed in a centralized database, and farmers, dealers, as well as other manufacturers can check out certified products of other manufacturers. And the next service is the AEF conformance test tool, where we would like to make sure that the isobus devices are compatible to the standard. It's one method to define rules and requirements in the standard, but someone has to make sure that the ECUs are acting accordingly. One additional point that I mentioned before is that we define also new functionalities. So we are extending the ISO standard, the ISO 11783 standard, with our guidelines. One example for that is the TIM functionality, which I will mention later. And the last service, at least for this introduction, are our AEF Plugfest, which we, at least in non-COVID times, host 2 times a year, 1 time in Europe and 1 time in North America. This is an overview for our AEF structure, let's say. We started this metrics organization beginning of this year, and I just want to show this structure. I don't want to dive into the details, but for the example of the TIM functionality, which was an initiative of the AEF, the TIM functionality can be seen in the highlighted row. And the reason why we have additional columns there is that the TIM project team, which already consists of engineers from our members, was supported by other AEF expert teams, like the marketing team, who were responsible to promote the functionality, the conformance test expert team, who were responsible to specify test cases and to implement test cases to make sure that TIM products can come into the AEF database, and already mentioned the AEF database expert team, who were responsible to create the architecture to show the certified TIM products. This is just as an example how AEF projects are organized and how AEF project teams work. The services that I already mentioned, first example is the Plugfest. These 2 are examples from 2018 in Bologna and 2017 in Lincoln in US. And as mentioned, we have 2 events each year, at least when we don't have COVID-19 around. And these events are hosted to give isobus developers the chance to test their software which is in development. We have 3 days of testing there, and for example, implement developers can test during the 3 days with different terminals, different servers, so they have always 30 minutes test slots on one table, and after 30 minutes they will walk to the next table and will have an additional counterpart to test their device against. The Plugfests are also used to host AEF project team meetings, because the project teams, they consist of engineers from multiple countries and continents and manufacturers, so it's not easy to get them all together for face-to-face meetings, and we used the Plugfests to host these meetings as well, because many engineers were already present due to their testing activities. The second service is the conformance test tool, which is used to actually certify isobus devices. We do have 5 independent test laboratories who are responsible to certify the isobus devices, but the tool can also be used by manufacturers to prepare for the actual certification. So they can test their software which is in development to make sure to really pass the conformance test as soon as they send their equipment over to the test laboratory. If they pass all sequences, they will, the manufacturer will receive this AEF certified label and a certificate, and then he's allowed to, on the one hand, upload the product to our database and therefore make it present for other manufacturers and for the agricultural world, and also to promote their device with the AEF certified label during shows, during fairs like this year. So if you go outside, try to find Isobus labels like this on the devices presented here. The last service I would like to roughly introduce is the AEF database, where the certified products are presented in the end. On the left hand, you can see our filter mechanisms. You can filter for functionalities like TIM, like task controller, like UT, and on the below this first screenshot, there's this mechanism to filter for brands. So you can, if you search for a specific John Deere or class tractor, you can filter for the specific brand and select the tractor model in this way. When it comes to the actual product compatibility view on the right side, you can see different icons again for the functionalities. So you have these dark blue icons for the John Deere tractor, for this example, for the supported functionality of the combination of tractor and implement. Because as you can see on the top, you have a tractor containing a TSU and a terminal, and on the bottom you have an implement. And for the combined functionality, so if the tractor has a UT server certified and the implement has a UT client certified, they are shown as this dark blue icon to highlight that this is a functionality that can be used for this combination. You can also see gray and not fully blue icons. The gray ones are not supported by the individual device, and the lighter blue ones, let's say, are supported by the individual device, but there is no counterpart in that case. Second agenda point is the general server client Isobus communication and idea. On the left side you see more or less the history before Isobus. So implements were delivered with a proprietary, let's say, terminal, or with a terminal from the same manufacturer, because the manufacturer wants to make sure that all features and all functionalities is supported by the terminal. So this has resulted in some kind of chaos in the cabin of the tractor, because if there were multiple implements for one farmer, he required 4 to 6 terminals to control all of them. And the idea of Isobus on the right side is to have one terminal being capable to control all implements from different manufacturers. So you can either use terminal in black, terminal blue, or terminal yellow to control each of the implements. That's the general message of Isobus, or goal of Isobus. A general data flow between server and client. In this case, it's the UT functionality. Well, first, the client waits until the server is active on the bus, and then the client starts to request information from the server, like what are your properties? Well, how big is your display? Do you have 280 times 280 pixels or 400 times 400? And based on all this information, the implement designs its object pool and its device description to deliver it and to make the terminal able to control all functionalities and all features. And this is not only the case for Universal Terminal, this is generally how the server-client communication works for AEF functionalities. Next agenda topic is the TCGeo and FMIS. We called it the perfect couple. First, I would like to introduce the example on the right side of the screen. The general task controller geo functionality enables location-specific data exchange for the entire system. So as the terminal and tractor combination, you can record speed rate values based on GPS data. And after the task is done, you can export the data into an XML file and store them on a USB device. This is one use case. But to make this circle complete, the FMIS comes into this change, into this process, into this couple. Because with the FMIS, you are able to create prescription maps before this task is already started. So you can create a prescription map within a farm management information system, export it in a standardized ISO XML format, and then the terminal with the task controller geo functionality is capable to use this XML data and to interact with the implement accordingly and to control the application rates in the implement accordingly. And afterwards, after the task is done then, based on these geodata, the loop can be closed by re-exporting the data from the terminal again into ISO XML and importing that again into the FMIS to do some further analysis regarding whatever, fuel consumption, just to mention one example. We closed this loop by developing the TCGeo conformance test for FMIS. So basically the exporting and importing mechanisms for FMIS systems can be certified from November this year on. And this is our measure to close the gap. Next topic is the TIM, Tractor Implement Management, and how we achieved cross-brand in-field automation there. TIM generally not replaces but extends the TECO Class 3 functionality, which is defined by the ISO 11783. And it extends this TECO Class 3 with additional AEF security protocols and mechanisms. TIM in general allows the implement to automatically control tractor functions like controlling auxiliary valves, controlling rear or hitch PTO engagement, or the steering and external guidance. The implement requests or can request these services as soon as both components are certified by an AEF test laboratory. The customer benefits for using TIM or equipping their tractors and implements with the TIM functionalities are that they have less operator fatigue and they are less depending on the operator himself. They can achieve increased productivity with TIM and improve their general job quality by these automation processes. Coming back to the general goals of TIM, so why has the AEF decided to start this project? And there are already the first TIM products in the market. The goal was to establish a multi-brand isobus automation with a transparent liability concept behind regarding safety and security requirements. They would like to establish a secured and controlled connection between this TIM couple and, of course, define clear processes, understandable for all engineers, how to implement the TIM functionality into the devices by specifying a guideline and requirements. Now I have the video. Andrew, can I find it on your laptop?
Hopefully.
I think the mouse is...
Is it still there?
Probably I should have it. Yes.
Yeah. Get the little. And just hit play.
Okay. So, as mentioned, we have already the first certified TIM devices, and yeah, I think early this year we decided to do a promotion video by the support of Klaas and Krone. And who else, Andrew? Do you know it? All the AEF members. All project team members. This video can be found on YouTube, and I posted the link into the slide as well. There we go.
My name is Jasper Jeninga, and I've been working in the past years within the AEF in the working group 5 on TIM automation, on ISOBUS automation. TIM is not a boy's name, it's the tractor implement management, which basically means an implement of any kind can request certain things from a tractor. And this means it can be the driving speed or to stop the tractor or a certain hitch position, PTO, engagement or speed, even steering commands can be sent with TIM. TIM can be used on any kind of implement as long as it's connected to ISOBUS. And it depends on the implement what kind of function we use. So here we see a round baler, and a typical use case with round baler is of course to open the rear gate and to stop and start and stop the tractor. So for opening the rear gate you have a hydraulic valve that you control, and for the start-stop, it's the vehicle speed. If you have another application, another implement, it depends on what process you have, what functions you can automate with TIM. Both the tractor and the implement needs the AEF certification for TIM, and any manufacturer can get the certification. They have to do the test, and then if they pass the test they can get it. And with this certificate it's basically multi-brand, brand independent. So if I have in this case a Krone baler, I can use it not only with Deutz but with any other tractor brand that's also certified, and the same for the tractor with any implement.
Die TIM-Funktion aktivieren. Nachdem das ISOBUS-Terminal des Schleppers die Presse erkannt hat, gehen wir in das Untermenü ISOBUS, dort auf die TIM-Funktion, und dort können wir diese aktivieren, damit Trecker und Maschine miteinander arbeiten können. Das Ganze akzeptieren wir und gehen schließlich wieder zurück ins Hauptmenü, auf der wir die Einstellung der Presse sehen können. Ja, ich bin Christoph Magritz, komme aus der Grafschaft Bentheim und ich fahre den Deutz mit der Varipec Rundballenpresse. Ich nutze TIM, da ich einen geringeren Dieselverbrauch habe, höhere Durchsätze und einen entspannteren Arbeitstag habe.
There will be different advantages for the driver, for the operator, and also for the farmer. So you will have increased efficiency. So you will have more output in the same time because you drive your machine more to the optimum, which also implies most of the times fuel efficiency. But it also relieves the driver. He has to do less tasks and he can reach the same quality during the whole day, or even if it's not an experienced driver, you can still have the same quality of output at the end. And in some cases you will reduce the wear of the machine because you don't overload the machine. So it saves also material cost at the end if you don't break your machine too much. And to know which ones are compatible, I can look it up in the AEF database where all these machines are listed. And then I can do the check, is my tractor with my implement compatible? Does it support the right functions?
Okay, yes, as mentioned, the video is available on YouTube. Yeah, as Jasper already mentioned, it's important in my point of view to give a statement in the direction for all other Isobus functionalities, at least until today. It's optional to get the AEF certification, but to manage the safety and security requirements for TIM, we made the certification required to use TIM. So it's not possible to use the TIM functionality without an AEF certification. One of the biggest challenges for the TIM team during specification and development are safety, liability, and security, because TIM is the first step in the direction of autonomous systems across manufacturers. And we as the AEF and the TIM project team especially managed this through defining safety, security requirements, but also during, with introducing a PKI infrastructure combined with the AEF certification. Next topic is Isobus conformance test. Of course, it's in one point to define requirements and another point to host AEF Plugfest to give manufacturers the chance to test their devices in development. But somehow there has to be an independent party to really control and certify the compatibility of the Isobus devices. And therefore the AEF decided to develop the conformance test tool. The conformance test tool, well, the first step are the published ISO standards and AEF guidelines and the contained Isobus requirements. These requirements are the basis for the AEF test specification and afterwards the test implementation and the resulting AEF test tool. As mentioned before, this test tool is then used by the 5 laboratories to certify Isobus devices, and therefore, if they pass the certification, giving them the chance to upload their products to the AEF database and make them public. The conformance test in general is separated into a physical layer hardware test and into a software test. During the hardware certification, the internal resistances, capacities are tested, as well as the CAN levels and power supplies. For the software part, it's then really functionality features like display features for the universal terminal functionality, security requirements as mentioned for the TIM functionality, or section control and application rates for task controller. For all Isobus devices on the software level, diagnostic data and some minimum requirements regarding capability to communicate Isobus are tested. So it's guaranteed that a device listed in the database can communicate on a minimum level through the Isobus. The resulting label, I have showed it before. This is the official AEF certified logo, and there are a couple of logos around, but as soon as you see this official one below, you can be sure to have an AEF certified product in front of you. Short summary about conformance test services. We do have conformance test stations on our Plugfest, so there's always a table where test laboratories, engineers are sitting and running test sequences against the device that you have brought with you to the Plugfest. We have as a service ongoing maintenance and bug fixing by the test implementation suppliers. And we have licensed access for test laboratories for the certification, and AEF member OEMs and manufacturers are also able to purchase a conformance test tool license and use it for in-house development and certification preparation. New conformance test functionalities. I have mentioned TCGO FMIS before, which will be released beginning of November, so in a few weeks. We have released the file-server conformance test early this year. Okay, next topic on my agenda are database updates. The database is available either through a web browser and also through the Android and iOS application. And I would just like to give a rough overview about some updates we did. So with these dots you can see on the bottom, you are able to swipe through different product versions of the product, and the combined functionality, which you can see on the top of this screen capture, they will change automatically if you swipe between software versions of one of the combined devices. You can also click on one of these functionality icons. In this example, it's the TIM client, and then you will find a short description of what TIM and TIM client functionality is about, and find some more details there in the app as well as in the browser. Especially in the browser version of the AEF database, we improved the compatibility view. Until today, you were able to see, of course, we have a UT server and a UT client, and they seem to be compatible, but there is more information regarding Isobus behind. The functionalities, again, have optional features and facilities, and within these detailed views here, you can also check for the support of the facilities. And in the example on the right side, you can find one column for the supported facilities of the client, one column for the supported facilities of the TIM server, and on the rightest side, the combinable facilities of the selected combination. One additional issue we would like to address is difficulties that farmers, dealers, and service technicians have with the support of the ISO XML format. So some farmers have issues with importing the ISO XML format into Isobus terminals, and the Isobus terminal just states, okay, it's an incompatible format, and the farmer has difficulties to understand what went wrong and why is it the wrong structure within the XML file. And therefore, we will in the future ask the terminal developers and the product maintainers of our database to upload example task data files as well as prescription maps to show this is how a prescription map should look like if you would like to import it into our terminal, or this is how task data should look like. So we would like to deliver some sample files there. So in the future, you will be able to select the TCGO icon in the compatibility view and find additional download information as sample files. Last item on my agenda before I will hand over to Andrew is the virtual Plugfest topic. I mentioned before, in general, we host 2 events a year, but of course, COVID-19 makes this difficult, 2020 and 2021. So we used, the hurdles for these Plugfest events are travel restrictions as well as face-to-face meetings, which were not allowed for some time. And as a measure, we used the experience of one of our members, Vector Informatik. They had experience in CAN remote diagnostics, where they tunneled CAN messages through IP in the automotive industry. And we asked ourselves, why shouldn't the AEF use this experience to try to establish remote Isobus connections as well? So we defined an architecture where the participants for the virtual Plugfest can install a desktop application developed by company Vector Informatik. They can connect their Isobus device through a CAN interface to the computer, and then they are connected through a cloud to another participants in a virtual room. We hosted this first official AEF virtual Plugfest in September this year with round about 85 devices, and in some we had 1,500 connections over 3 days with multiple terminals, TC servers and working sets, and also 3 FMIS connected. And as you can see here, we had participants from all over the world, and they were all connected virtually. So we introduced Microsoft Teams meetings instead of having physical tables on a Plugfest event. And these Teams meetings were used to create peer-to-peer connections between, for example, terminals and implements. And on the left side, you can see a part of our Plugfest matrix. This is, as an example, a schedule for a client from Echo who participated, and he has 30-minute slots, and the Microsoft Teams links were directly implemented in this matrix, so they had just to click on these links and were directed into the Microsoft Teams meeting, and then were able to communicate with the counterpart. As a summary of the results and a short outlook, we had a successful realization of this first virtual Plugfest. There's interest for more events. We as AEF, we know that these virtual events will never replace the physical events and the benefits we have from them, like networking and spending days together with conversations between the slots and so on. But this can be a nice extension. Imagine you have a test slot during the Plugfest and you recognize an issue that cannot be fixed within hours or within a day. You can schedule, for example, a 1-hour virtual session for 2 weeks later. We know that there are room for extensions, and we hope for additional events in the future. And that's it for my part. And if there are questions, feel free to answer them, or should we do it after your presentation, Andrew?
It's up to you. It's up to you.
Okay, so if there are questions, feel free to ask.
Not so far.
Okay, otherwise I will hand over to Andrew.
Okay, thank you, Marco. Let me just get set up here. Get rid of that one.
Please, if the farmer detects some trouble in some implement with the tractor, can he then send it to AEF?
Good question. As one additional service, the AEF offers Isobus check tool through our database. This is an application that you can install on your computer. You can connect to the Isobus system with a CAN interface, and you can scan the diagnostic messages. And the application will create a file which you can upload to the database. It will detect which manufacturer is part of the system, which software version is used in the system, and during this upload to our database, the database detects these manufacturers, for example, a combination of John Deere and Amazoni, and you will be able as a customer or as a dealer to contact the manufacturers through our database and ask, is this really the latest software version? Or can you come over, or can you look into the log file that I provided through this ticket here? So there are mechanisms to contact the participating manufacturers.
that if they rectify one mistake, then sometimes there's something else going wrong. And if you rectify one, how that? Yeah, I've heard that. Is that true? Sometimes in the CAN messages you rectify one thing and then something else is broken or so, or on the tractor.
At least in the database, you have the chance to stay in contact with the manufacturers, also after they have proposed a solution or sent a technician. Anything to add?
No. Not too much to add. Just to say that in general, it can happen with any system that you might have one issue which you resolve, and then that exposes another issue. But it might not be limited to the tractor and implement hydraulics. It could be something, or sorry, electronics. It could be something else going on in this, with that combination. Okay. Are there any other questions? Okay. Hey, so listen. My name's Andrew Oliver, and thank you, Marco, for giving us this sort of overview. Let's say more of the technicalities, the things that we've got today, the conformance test, the database, and that kind of thing, and the Plugfest. I'm going to speak about a couple of subjects now. There are, let's say, well, the AEF has a lot of project teams, and if you might remember from the slide from Marco, he showed the slide of the reorganization, and we had our sort of project teams down on the left-hand side, and he mentioned one of those project teams, which is the TIM project team, or Isobus Automation. There's also other teams looking after the database. There's a communications and marketing team, etc. And basically, one of the things about the AEF is that we rely on the support of our members to volunteer time from their employees to support what we're trying to do, because essentially we were formed to collaborate on unfortunately it was a problem. Isobus seemed to be a great idea when it was first announced, but then it quickly became a problem because we were all developing Isobus components which didn't work with other components. And that was really the reason why the AEF was formed. But it's because of this collaboration we have between all the different manufacturers that we get together, we see an issue, and sometimes we form new teams to work on that issue to try and enable more compatibility, more interoperability within the ag world. And if any of you have been to our booth in Hall 36, yes, you can see a nice totem which is kind of rotating, it's quite mesmerizing. Anyway, in the totem, it actually lists all the member companies that belong to the AEF, and kind of, as Marco mentioned, we're up to almost 250 members at the moment. So it's quite impressive, this spirit of collaboration that exists within the AEF. And yeah, basically, so I'm Andrew Oliver. I work for CNH Industrial, so Case New Holland, Case New Holland Steyr, depending on where you're coming from. And some of my time I spend to support the AEF and its activities, and it's with that I'm the vice chairman of the AEF, and so I'm speaking to you today with my AEF hat on. Now, I mentioned AEF collaboration and project teams, and I'm going to speak to you now about sort of two of the teams which, yeah, we've got about 13 or 14 teams at the moment, but this is actually one of the latest ones that's been formed, and it's the team called Agricultural Interoperability Network, or AgIN. You can tell already that the C&M team have not been involved because this name is a bit clunky and we need to come up with a better name for this team, but that's another story. So the AgIN team was formed around about July. We had our first sort of kick-off meeting. The whole idea of the AgIN team is that, let's say our vision is we want to provide a sustainable and industry quality matching interoperability structure to connect multicolored online platforms through harmonized technologies. what is this going on about? Really, the whole idea is we've realized that there is this growing need or growing urgency, this growing problem within the ag space of everybody developing cloud solutions. And there is this need to provide an easy or a standardized way to allow these cloud solutions to connect. And that was really the reason behind forming the AgIn. So if we look at our value statement, it's for ag software providers who enable their customers to use their ag data in any ag platform. AgIn is a concerted and non-discriminatory governed network that streamlines, or will streamline, peer-to-peer interfaces to other platforms. But unlike today's multitude of solutions, our solution ensures reliability and trust in the services in the network. And you might think, okay, this is really quite a big problem, and what we're trying to do here is quite a big, we're trying to bite off a big piece of the, we're taking on a big challenge. So we knew that we needed to put a lot of different things in the scope of this project team, and as I've kind of mentioned, we had a kickoff meeting in July. We've had about 3 other meetings since then. We've got some pretty good engagement from companies with European employees and also companies with North American employees as well. So there's been some pretty good engagement, and we're actually, in the next few months, going to break down into individual teams working on different subjects under this topic of AgIn. So what's in scope of the AgIn? We need to work on service design, so services to support the different use cases of our customers, of the AEF members. We also need to work on infrastructure, so the design and implementation of the technical infrastructure to enable this secure interoperability network. Obviously, we need to be exchanging data, and so we need to harmonize the data exchange. We need to look at the existing data exchange standards and initiatives, for example, like Gaia-X, and then we need to refine and harmonize data transportation for formats and semantics so that we can minimize the multiplicity of today's solutions. And then, because we're the AEF, we always need to develop a conformance test. We need to develop a product which can be tested in some way so that people can release a solution which is up to a certain standard, a certain level, and that's always reflected with a test. We also need to develop a participant directory so that people can understand who is participating on this network, which services can I use. And again, because we're the AEF, we're always going to release something in the form of a guideline, and a guideline is something which all our AEF members can access and follow, and it will help them to develop something in this area. What's also in scope is some type of legal framework. So we need to work on a type of legal design and implementation of a legal contract framework. And again, I'm sure that some of you have had experience with GDPR, with trying to connect clouds in Europe. You'll understand that it is a bit of a nightmare, and we need to have some type of standardized contract as well that we can all follow. Whenever you release a product, you need to have some type of support process for it, and then obviously you also need to market and sell the product as well. So all of these things are actually in scope of this new project team, the AgIn project. And again, similar to other AEF products we have on the market today, such as the database, this AgIn network, we actually need to be able to support it. So once the project is over, we need to keep it running. We need to keep this product running, and so we need to have a type of we need to have someone responsible for the product. We need someone to decide on what additional services are added to the product. And then we need a bit of a team to respond to any bugs, any issues with the system as well. And then obviously, you know, we always need to keep the lawyers engaged to make sure that our legal standards or our legal contract is up to scratch. So it's not something that we can, let's say, it's not just a project which has a start and a finish date. This AGIN, this interoperability network, is going to start and, you know, move forward. So another way to look at it, let's say to try and look at it visually, is, you know, what is the AGIN? Well, one part of it is it's a network. And the network, it's a network which ensures trust and reliability through, you know, well-known AEF security and conformance test procedures, which, you know, is one of the reasons that AEF has got its name. We obviously need to be supporting some use cases. So the use cases are really specifications that define what people are going to be doing, what things are going to be exchanged on the network. And then, as mentioned before, we've got that contract piece as well. And we need to come up with a contract framework that offers this simplified contracting for participants in the network. And let's say this contracting thing is really quite an important piece, because a lot of the AEF members who are currently in the AGIN project, and one of the reasons for this project to be kicked off is a lot of us have had experience with other data sharing, cloud connecting initiatives that are on the market today. And one such example is Data Connect. And for the people that are involved in Data Connect, for the companies that are involved in Data Connect, the actual legal or the contract framework has been one of the most nightmarish processes, trying to get these companies to align on how data can be shared, but still reflecting the customer's, you know, rights with regards to GDPR. So one of the things that the AGIN has to address is a simplified or a standardized contract framework. So if we look at the network, the target group for this is really the OEMs. So these platforms that need to connect, whether it's a company that makes tractors, whether it's some type of FMIS product, which is taking the data from the field and processing it, etc. We want all these people to be able to connect their clouds. As far as the specifications for the use case, essentially we're looking after the customers there, we're looking after the farmers. What do they actually want to do with the data? Where do they want it to go? What type of data do they want to exchange? And we're trying to look after the farmer with that, with the use case solutions. And then finally, kind of back to that contract piece, the target group is really both the platforms that want to be sharing data, and then also the customers who are allowing their data to be shared. We're trying to make that process a lot simpler. So we've tried to choose these triangles to sort of represent the shape of the AGIN product. However, I'm sure there are also some more, let's say, software, hardware, architecture-based people here. So let's talk a little bit about what the architecture we think it will look like for the AGIN. And if you look on the left-hand side of the screen, you can see that box which has got the AEF, and all those things on the left-hand side, they kind of represent AEF products today. So we've heard about the database before, we've heard about the PKI infrastructure. Marco mentioned that when he was talking about the TIM functionality. We've heard about the conformance tests as well for the different Isobus functionalities. And one of the new things we need to develop for this this product would be simulators, standard simulators which people can use. Looking at the right-hand side of the slide, we have the different participants that there would be on the network. And these participants could be, as I mentioned, all sorts of different companies within the ag space. So you could have the OEM participants, so they're represented by Platform 1. Platform 2, that's an indication of an FMIS provider, for example, that would be processing the data coming from different machines or exporting prescription maps out to the machines. And then Platform 3 is an indication of some other actor in the ag space. It could be some type of in-field sensor which is connecting to its own cloud, but it obviously needs that data from the cloud to get out to other clouds as well. So, part of this project team, we need to develop some API simulators, and those simulators would be available to the different participants in the network to test their API is performing, is responding in the same way. Oops, wrong way. Once we had these simulators, we need to develop a conformance test for these different platforms that would want to connect on the network. And this conformance test would certify that a platform supports, let's say, a particular service on the network. And again, similar to that scenario with Tim, once you have a platform which is certified to connect to the network, we would generate a type of security certificate, so that using this PKI infrastructure that each platform would have to hold on to, because that's important for the security handshake. And then finally, once we had the certification, once we had those security certificates going around, we would need to develop a participant directory. And that would be so that anybody, it could be other OEMs, other platforms, it could even be customers, could actually look up and see which participants there are on the network and what services they offer. So, finally, once we have a participant directory, then each of the participants, each of the different services on the right-hand side, they would need to register and say, hey, I'm part of the AGIN network and these are the services I offer. Obviously, they would need to be certified, because that certification generates that certificate, that trust certificate, which everybody would need to certify and then include on their platform, and that creates the trust piece. But then finally, once each participant has been registered on the participant directory, they have their certification, they have their trust certificate, then they can communicate platform to platform directly, and they don't need that kind of AEF part. And so I mentioned before, this is a peer-to-peer network, and this allows these platforms to communicate directly without some central authorization, none of that, no data storage, etc. It's a peer-to-peer network. So each participant, they do the security handshake with another participant on the network. Once they verify that, yes, you're a trusted partner on the network and so am I, then they would actually start exchanging data based on the different services. And one platform could be supporting one service, another platform could be supporting 2 or more services. Basically, once you're registered on the network and then you're certified for 1 or more services, then you're free to exchange data with other partners, obviously based on what your customers want to do. And that's the whole idea of the AGIN network. It is a peer-to-peer network with certification, with trust created and provided by the AEF. Every now and then, each participant would have to, if you like, check in again with the AEF, with that compliance and trust piece, to make sure they had the latest certificates, to make sure they were, let's say, current or certified. So that's the idea behind the AGIN. We've spoken a little bit about the product, and we've spoken a little bit about the architecture. Like I said, we've had about 3 or 4 meetings so far, and we've got good participation from the AEF member companies, good support from the companies who have clouds that they do want to connect together. We're envisaging having about 6 different project teams led under the, if you like, project management. So a legal, marketing and business, and then also, infrastructure, architecture and data harmonization. So we envisage having these 6 project teams. As a way of getting started, we've actually split the group that we've got of about 30 different companies. We've split them up into 2. So we've actually got a legal, marketing and business case group that need to work on specifically those subjects. And then we've got a second group which is more technical, so infrastructure, architecture and data harmonization. Ideally, as we're moving forward more, we'll actually be breaking those down up into these 6 different teams. But for now, we're sort of moving forward this way. Obviously, we're all experiencing the effects of COVID, and it would have been much nicer to have a face-to-face kickoff meeting to get all the interested parties in one room, spend the afternoon together talking about this, breaking up into these individual groups already and to start to work. But really, with the COVID situation, we've done everything virtually in sort of 2-hour slots, and it means instead of things moving along in weeks, they're kind of taking months. However, I think we're really starting to move forward, and I think it is quite an interesting project. It's obviously quite topical, and if there's anybody here from AEF member companies that would like to participate in this group, don't hesitate to contact us afterwards, or go to the AEF website and contact the office, or come to the AEF booth in Hall 36. Yeah. Okay. That's it for AGIN. My next subject is wireless and field communication, which should be that one. Okay. Does anybody have any questions about AGIN just now, or there'll be time at the end for questions as well, if you want to think about it a bit. Yes.
Just a second. Because then we are live streaming, so people can.
Sorry.
So you talk about information of the sensors that goes into the cloud.
Yep.
But what information is it then? Is it about? Is it on the field? It is on the. If it's operative, then is it that information or?
Yeah. So. Specifically, if you look at that, if you think back to that slide in participant 3 on the network, we talked about in-field sensors. And, as you've seen around the show, there are a lot of suppliers of weather stations, soil moisture sensors, etc. And all of these suppliers typically have their own cloud connection. They say you put our sensors in the field and then you connect up to our cloud, and you can see a certain amount of information. And the whole idea of the AGIN is to say that not only are you able to see the data in the cloud of the sensor, but you should be able to pull that data to whichever other cloud you want to see it. Typically, people want to pull all their data into some type of FMIS platform for analysis, for saving, etc. And this is really the whole idea of AGIN, is that anybody who has a cloud solution with some type of agronomic data, whether it's come off the field directly, whether it's come off the tractor or the implement or the combine, if the data's in some type of ag cloud, we feel that all that information should be able to move to any other ag cloud, and we want to try and standardize that. So with standardized APIs and a standardized contract mechanism to make it easier to form these partnerships.
Yeah, but with the partnerships, does it go? Is there then some scientific research with it, or like, yeah, they say they can from the satellites they can see what the harvest will be in that time, and then they can see how the prices of the grains are gonna be.
Yep.
Oh, is it about predictability then too, or and
no,
then about scientific research? And
it's not to do with scientific research. It's about connecting clouds in the ag space and having an easy way, a standardized way of connecting clouds. The connections are, if you like, cloud to cloud or business to business, but in the end, it's the customer's data, and the customer's got to choose. Okay, I want my cloud from this platform to go across to that platform
the
because
farmer, you mean? Then?
Yeah, the farmer, the customer. Yeah.
Oh, there's is then his information encrypted, or from like in WhatsApp end-to-end encryption, or no?
Yeah. So as far as I mean,
I don't know much about computers.
No, that's okay. So the actual, obviously, that if you have some type of sensor service in the field sending data up to the cloud responsible for that, then yes, that information should be secure, and that's the responsible of the person whose sensor and cloud it is. What we're talking about here with this AGIN network is again a way of connecting one cloud to another cloud. But yes, we need to respect the customer's data privacy. We need to respect the security of the data as well. That needs to be ensured. All those things need to be taken into account as we develop this interoperability network. Does that answer your question?
Yeah, I think, yep, but yeah, it's at data mining, or can they then with that data sell that data for other third parties? Or?
No, I mean, again, we're not.
Yeah, sorry, but
yeah,
but I'm with this question. I'm sorry.
So the whole idea of this is to make it easier for the clouds to connect, but the customer of Cloud A, he needs to decide that he is happy with his data to go to Cloud B. And he needs to have an account on Cloud B. And if he doesn't allow that, then that data is not going to move from Cloud A.
Okay.
Yeah? So it's always, the customer's got to decide which connections or where he wants his data to go. That rule is always there. Yeah? Okay? Okay. All right, any other questions on the AGIN? Okay. So, it's still me, and now I'm going to speak about another AEF project team, which is the Wireless In-Field Communication Project Team, or WIC. Yeah, I'll try and basically we'll give a little bit of an explanation of what's behind this project team, what's behind what they're trying to do, what are some of the conditions, and then really what's the status of the team, where are we today. So, yeah, WIC, or wireless in-field communication, is really about we've gone from the cloud to connecting clouds now, we're back in the field. We're talking about machines working in the same field or in adjacent fields. And, yes, with our AEF, yes, we've started off because we have this wired connection between tractor and implement using a standard called ISOBUS, which, we needed to collaborate to make this ISOBUS standard work. And we've obviously realized, along with, a lot of people in the ag space, that there's also a need for wireless connection between machines working in the same field. And this wireless connection should be between machines that are from different manufacturers, because nobody uses a single color fleet anymore. I mean, especially in Europe and North America, there's still that possibility, but in Europe, it's not really feasible. Everybody's using a mixed fleet. There's mixed fleets machines working in the same field. If they can exchange a certain amount of data while they're working, it can actually make their operation more productive, more efficient. And yeah, so there are different use cases that we're trying to address with this wireless in-field communication. There's the use case of process data exchange. So where have I driven in the field? You know, let's say to make sure that the next machine is not driving in the same space. The process data exchange could also include not just coverage maps, but it could include guidance lines or boundaries, etc. The next use case that we're addressing is the cooperative machines. Some people call it platooning. And in that use case, you have one machine doing something in a field, such as a combine driving forward, and that combine might be ready to unload. So in this case, the tractor with the trailer comes close to the combine, and as soon as they're close enough, the combine can actually take control of the tractor and make sure the tractor stays alongside the combine. And that control of another machine which is close by, that's platooning. There's another use case which is this high volume data streaming, but in a simple word, it could be you have a digital camera on one machine and you have the terminal actually on the adjacent machine, and you have a wide wireless connection there as well. And then finally, there's that fourth use case we're addressing in the WIC team, which is the road safety. And it's about the ability of a slow-moving ag machine to be able to communicate to other road users as they're about to move out onto the road to say, here I am, and I'm not driving very fast. You know, some of the boundary conditions for this type of technology or wireless in-field communication is really the fact that, you know, obviously farming goes on in rural areas. And in rural areas, we don't have this infrastructure that we benefit from, you know, in cities. So where I live, you know, they're currently in the middle of rolling out this wonderful 5G network, and I've already received the offer that if I want to upgrade my phone, I can surf on 5G for free. But obviously, you know, out where they're growing crops, there's no 5G, there's probably sometimes not even 4G, and by the time the infrastructure gets out there, well, we'll all have grey hair. So the idea of this wireless and field communications is it needs to work where there's no infrastructure. We have this need for machine-to-machine communication. As I mentioned, you know, we've got mixed fleets going on today, and so this communication must work between machines which are not from the same manufacturer. If you like, the other constraint or the other thing that this team has to deal with is we're working on something which essentially would become a standard, and standards can be used globally, and a lot of the AEF members are making equipment which is used around the world. So we have to come up with a technology which is suitable globally, not just based on European standards or North American standards or Japanese standards, whatever. We need to come up with a technology which will work globally. And yet, you know, needless to say, we also need to make sure we develop something which is robust enough for being used out in the field. So we've got this WIC team, we know the use cases, we know some of the boundary conditions. What are the objectives of the team? What are we trying to do? So we're trying to define interfaces and guidelines which support the use cases we spoke about. To make this thing more successful and easier for manufacturers to adopt in the future, we actually want to be developing some common WIC software, and common from the part of the communication point of view. So it's a type of, let's say, middleware software that we want to develop to enable the required communication from one machine to another to go in a simpler way, an easier way. And that middle with that communication software would actually support proprietary as well as interoperable solutions. And then, you know, we spoke a little bit about the cloud solution before and the need for security and privacy. The solution that we're developing must also respect that as well for this machine-to-machine communication. We also need to securely identify machines and make sure that the data exchanged is protected. And then because we are connecting to machines, we need to ensure safety, and we need to ensure that we're up to a certain level of ISO 25119. So I can never say it properly. PLC.
Yeah, agricultural performance level.
Agriculture performance level C. Thank you, Alessio. So, kind of, what's the status? Now we'll just have a look at the radio technology, and then we'll look a bit more at some of the use cases, and we'll get a bit of an overview of where they are. So, as mentioned before, it's the WIC team, and we're talking about a wireless communication technology that has a long range and is robust, so that we don't have a need for infrastructure. And so really, the idea of this team is that when we were looking at the time to market and cost, we wanted to pick a technology that's already available and proven, so that we can tailor it according to our needs. And if you like, you know, I don't want this to be a history lesson, but as an analogy, if you look back to 20 years ago, when the ag industry was using CAN in J1939 as a basis for Isobus, this is kind of a similar story. And really, after investigating, you know, the different technologies, the choice became this IEEE, so 802.11p radio standard. This was originally developed for on-road applications, so-called Connected Intelligent Transport Systems, or CITS. And the use cases that we're talking about in field are very similar. So it seemed to be the right technology to use, as it would be suitable for our use cases. So this 11p, it's based on Wi-Fi technology, but it's been tweaked to be more robust and to support these ad hoc networks. And you can imagine that if you've got machines driving in and out of range, they need to suddenly pair and then unpair. There's already, let's say, some higher level protocols available, so dedicated short-range communication for the US, and then this ITS-G5 for the EU. And there's a dedicated frequency spectrum, so this 5.9 gigahertz is available. It comes with low latency and was designed from the ground up for safety relevant use cases. And you know, we've already tested this technology in the ag space, and we found that it's actually quite suitable for what we want to do as far as in-field communication. So one of the use cases is road safety, and about, well, it must have been 3 years ago now, a prototype was presented at an ETSI IoT week, about 3 years ago. The goal of this project, which was funded by ETSI, was to make machine information available using a generic machine interface like Isobus and the one-to-one platform, M2M platform, which was also supported by ETSI. Now, since we used this IEEE 802.11p, direct vehicle-to-vehicle communication was possible without the need for any infrastructure. And so that allowed the ability for cars to be warned about a slow tractor coming onto the road. The next use case is this, platooning use case, or let's say cooperative machines. Many OEMs have had a lot of experience in this technology with, more than 10 years of connecting machines wirelessly. And you can see in the top picture there, Fendt, they showed their Guide Connect system with one manned and one unmanned tractor. And I think that was almost 10 years ago now they showed that. So it's possible to have this connection, this control wirelessly, but yeah, again, it's within the same brand of equipment. So there's solutions in the market from Deere and Trimble as well, and then Class, even they demonstrated an 802.11p based version within a project which is called 5G Net Mobile. And now really the team is taking lessons learned from these activities and aligning with other on-road platooning projects and approaches. So really, we're currently defining the general approach to platooning, and we're trying to work out if it should be centralized or decentralized. And then that obviously affects the communication interfaces and the safety aspects, etc. Okay, and then let's say the last use case I wanted to touch here was this process data exchange. And yet, process data, so it's that information, what am I doing in the field right now, where am I, am I exchanging coverage maps, am I exchanging guidance lines, boundaries, etc. And yes, in this case as well, there are proprietary solutions available. So if you have the same display in each different tractor, then typically you can send data wirelessly from one display to another, but they need to be from the same manufacturer. So the idea of this team is, again, we want to have this communication in the field between different manufacturers. We want to be able to exchange where I've been, what I've done, etc., directly without any infrastructure. And then, yeah, some of the challenges here seem to be the data, how far away one tractor can be from the other. And if you go out of range and then you come back in range, when do you send the data, etc. So this might seem like the simplest use case, but it also has its complexities as well. Okay, so now we'll just have a quick summary of the WIC activities. Really, so today we spoke about the goals of the WIC team, so focusing on this wireless in-field communication. And we spoke about the use cases and the fact that, we feel that for the WIC activity to be successful, we, the AEF, or this particular team, we actually need to be developing some type of software, this called middleware, which makes the communication piece a lot easier. So manufacturers who start using this technology don't also have to worry about writing the communication software. We feel we should be providing that. I mentioned before, we've also, we've selected the right, let's say, radio technology, this 802.11p, and then we've started some cooperation with some other entities in this space, such as Car2Car and Etsy. We've also done some field testing to prove the suitability of this chosen radio technology. And really, from where we are, the next point is to start implementing some type of this common software, this middleware. We need to start working on that. We also need to have awareness of what's going on with the cellular networks in the future to see if there's some evolution in the Wi-Fi domain and see if something better turns up. Now, the one thing I also wanted to show you here whilst I remember. Is it this one? Sorry. Here we go. So, just as, oh, now I need to do this as well. Haha. See, I know how to use a computer. So, the WIC team, obviously they've been quite active, and recently, although I think it must have actually been before the start of summer, we did do a field trial in Germany, and we managed to get 3 different tractors in the field. We fitted them with this WIC technology, and we tried out this process data exchange use case. So I've got a short video here which talks a little bit about that, and hopefully we can play this now. Yeah, April it took place.
My name is Norbert Schlingmann. I'm the general manager of AEF. We see tractors in the field which works together, and they are connected to each other with an 802.11p connection, and they are connecting information. They are sending information from one machine to the other machine.
So my name is Johan Witte. I'm with Klaas. I'm there responsible for advanced development at the business unit Grain, and I'm also team lead of project team 11, wireless in-field communication of AEF. At least on large farms, we are seeing quite a lot of cooperative work of machines. So not only a single machine on a single field, we are used to see more than one machine on the same field doing the same work, or doing, let's say, work which is somehow connected. And today we are not able to share their data between these machines in a direct way. So you have to use a USB storage device, or you have to use some cloud solution which always take a certain time to exchange the data, and which is almost not real time, so not within seconds. And that is a point where we see your potential to give their tool to our customers, working there much more efficient if they can share this data, like coverage data or AB lines or field borders or other stuff which is relevant here from an AEF or from a manufacturer's position. We see there a big benefit to have their solution which is, let's say, colorblind. It doesn't make sense to have their green to green or red to red feature. Our customers are having their mixed fleets using tractors and implements from different manufacturers, and AEF is taking care that everyone is able to talk to each other.
See the shared coverage from both machines. In blue is the Fendt tractor we are sitting on. In pink is the Klaas tractor. The advantage would be that, for example, in those conditions you clearly see where the other machine already worked. In other conditions, for example, during the night.
Okay, sorry, I just wanted to show here this is an example of, you've got both machines going side by side from different manufacturers, and you can see that the second machine, it knows that the first machine has driven on the left, and so it's already switching off its coverage or its application of that second machine based on what it's getting from the first machine. And this is one of the cool things about this technology, is this process data exchange. One thing I also wanted to, let's say, apologize there is, yep, we took this video in April, and you know, like everything else, there was a lot of the effects of COVID going on. And the cameraman who also records the sound, he couldn't actually travel because he got diagnosed with COVID the day before. So this is the director making this video with his cell phone. And the wind. So that's why there's a lot of wind noise here, and I think we might have to go back into the field this springtime and try and re-record this. Anyway, are there any questions on the WIC technology? If I can do this.
Yeah, that's just because from the same. It's like a Muller screen could send to another Muller screen. Or yeah, but just because of this, of the terminal, one terminal can send to the other terminal.
Yeah, so I guess I cut out a box there. It depends typically on the terminal and the modem that are in the tractor. So yes, there are some companies today who have a solution where if you have their terminal and a modem in tractor 1 and also in tractor 2, then they can communicate wirelessly within a certain range. But obviously all the components must be from the same company. And those components might not actually be the standard display that you have in the tractor anyway. So it means an additional display, etc. But yes, there are products on the market today for wireless and field communication.
And there was on some slides something, and I couldn't follow, centralized and decentralized, and I didn't know what you meant.
So that's kind of getting into the specifically talking about the platooning use cases, and that's kind of getting into the weeds or the technicality of how we can support the platooning use case. And I apologize because I'm from marketing and I don't understand that statement either.
Platooning, is that then the same as master and slave thing?
Yeah, similar. The whole idea with platooning is that if you've got two machines within range, then machine A can take control of machine B and tell machine B how fast or slow to go and possibly even how to steer.
Okay.
That's the idea of platooning.
Any? Yeah.
Thank you. First question is, if I understood correctly, we're not bound in using Isobus standard for this group or not?
So currently there is no standard for wireless and field communication.
Okay.
We're working on trying to do something in that area.
Okay.
Yeah.
Second question is, I've seen always tractors in the use cases you considered.
Yeah.
Have you considered something else?
Do you have an example?
Yeah, irrigation rails.
But
we have different control units.
Yep.
For example, controlling the rewinding of the pipe, the sprinkler, the motor pump, and so on. And they are most of the times manufactured by different manufacturers with their own control unit, and there is a lot of need of standardizing their communication.
Wow. Yeah, so from the point of view of the AEF, no, we haven't, because the AEF is a group of tractor and implement manufacturers who, let's say, first of all, we were formed for this, to make the Isobus system work between tractors and implements, and now we've realized there's this need for communication between machines in the field. But I guess currently we don't have any irrigation equipment manufacturers that belong to the AEF that are bringing this subject up.
This could be the first one.
Yeah.
Yeah, actually we do not build irrigation rails, but we work in the irrigation field and also in the distribution of products. So the irrigation area is actually a gray area where there is no standard, and it would be really needed. I suggest you to consider also that. So
it's kind of interesting because are there any standardized organizations that work on irrigation?
As far as I know, no.
Okay. So within the AEF, we have another project team which is working on, it's called High Speed Isobus. And this particular team is working on, how can we increase the speed on the Isobus? Is it some type of Ethernet cable that goes between the tractor and the implement? Does it need a special type of connector? What sort of messages can go on there? Anyway, the point is that this HSI team, looking specifically at the tractor and implement working in the field, has discovered that there are other industry groups in construction and in on-highways, so specifically trucks and trailers, that also have the need for the same technology. And so this AEF project team working on high-speed isobus has started collaborating with an industry group from construction and an industry group from on-highway applications, the truck world. And it could be a similar scenario where we need to understand, is there some type of industry organization for irrigation systems that are looking at this, and can we collaborate? Because it would be interesting to try and, it's always interesting to develop a technology which has, if you like, more than one market or more than one sector where it can be used.
As far as I know, there is no such kind of organization. But actually, no, okay. Actually, there is a lot of need for that. I mean, it's there are a lot of there are a lot of manufacturer of rails, yep, of sprinklers, of motor pumps, and control units for managing each of different of those, yep. And you know, when there are farmers that have to buy 4 different SIMs for managing 4 different control units, yeah, okay, all of them put on a single machine on the field, which is used for 3 months a year. Yeah, okay. So it's they are getting mad, actually. Really.
Imagine. Yeah, I can imagine.
Can I add a word to that? Sure. So the point is that, as Andrew already mentioned, AEF was formed by actually tractor and implement manufacturers and components of electronics manufacturers, I would say, but it's not close to that. I mean, irrigation industry is part of the agricultural industry, so if there is an interest from those manufacturers to jump on board, because anyway, these technologies can be used for any use case. So we identify the use cases which are right now in the area of our members, which are, again, tractors and implement manufacturers, basically. But if we can have on board, for example, irrigation products manufacturers, that they can bring their own use cases, and they can be worked out in our project teams, right? We can identify use cases. Wireless in-field communication is a technology that can be used for any type of use case we can identify, basically. Of course, there's an effort in the implementation, but if we can't, let's say, imagine what is needed if we don't have on board the actors.
And I think, yeah, thank you, Alessio. So we've mentioned a few times today that the AEF started as a cooperation between manufacturers, and people volunteer their time to support the AEF and to support project teams. So in this case, you know, I could imagine that yeah, so let's get a bunch of manufacturers of irrigation components, A, they'd have to join the AEF, and B, we would have to create another project team. But each of those manufacturers should be prepared to send someone to these meetings to be able to collaborate on this particular issue. Yeah, so it's an industry collaboration group. So one thing is joining, and then B, the second thing is saying, okay, I've joined this group, I now need to support it with my time or some of my staff's time who are the technical experts in this area. And it's by companies volunteering their time that we have this collaboration, and we can end up coming up with AEF guidelines and then standards, and you know, we spoke about WIC and this idea of actually having some type of common software. But people need to be prepared to dedicate time to this, otherwise it doesn't work. Yeah, but this, I mean, this is interesting, and it could be another, let's say, addition, expansion, or direction for the AEF.
Yeah, absolutely. Yeah.
I don't know either. It's a new world to me.
We had a lot in here. We have an irrigation, well, a water treatment area here in the fair, and we have a lot of manufacturers here. And they are, for example, working, most of them are working these 4.0 solutions to provide data that it can be used, you know, for water savings and so on. And of course, you and all of your, let's say, competitors have such a kind of interest in having or joining such a kind of projects, having such a kind of solutions. But as Andrew mentioned, we need both the input, because there's a need for that, and second one, the knowledge and the skills and the background to solve those issues, because as a tractor manufacturers or implement manufacturers, I don't know which are the requirements for an irrigation system, for example, right? So we need your expertise on board to solve those issues. AEF actually is doing the interest of their members, basically, and it's try to find out which are the needs of their members, and not the one coming from the outside, let's say. But if the other, let's say, other actors jump on board and bring their own requirement, then, and there's strong enough, let's say, and resources enough to be spent on such a topic, then something can be worked out for sure.
Okay. Okay. Now, I think it's a good time to conclude.
Yeah.
Yeah?
I think so.
So, just to go through, let's say, you know, a couple of slides, and you know, we're here learning about connectivity. We're here learning about agriculture 4.0, and really, I think one of the interesting initiatives for the AEF really was the ability that we managed to host this virtual Plugfest this year. This was a request that surfaced about a year ago, and you know, thanks to Marco and his team in the office, they actually managed to make it work. They had 2 or 3 trials before this September event, and in each trial, the first one there were 10 companies, and then the second one was 30 companies, but they actually managed to do it. They managed to have this virtual event over 3 days. And yeah, really it was quite impressive, but even using the internet, we could have Isobus connectivity and compatibility. Looking forward to next year, we really hope that we're going to be face to face with some real Plugfests. The first one next year is going to be in March, early March, in New Orleans, and it's in conjunction with a kind of an ag show over there called the Commodity Classic. So that's going to be quite an interesting event, because we've never really done a Plugfest that early on in the year, but that should be quite good. And then next year in October, we're going to be back here, just sort of over the road at the Savoia Hotel, and we'll be there for 3 days having our fall Plugfest, or autumn Plugfest, we should say. And then, you know, being the AEF, we typically organise a bunch of meetings, steering committee and team leader meetings, and when we're back here in September, we might even have a conference day which would be open to the public to come along to. You know, fingers crossed that actually does come about, and yeah, things start moving forward and not backwards anymore. Okay, there's another couple of things we've done, because if we come back to the original idea of the AEF, and it's to make things compatible on the Isobus, and we developed this this database, and the idea is that products which pass the conformance test can be listed in the database, and that's available to the industry to access and use and look for Isobus compatible products. We've found that we still don't have enough companies that are making Isobus products, certifying them and putting them in the database. So just recently we've announced this kind of reduced membership offer. The idea is to attract small and medium-sized companies, A, to join the AEF, and B, to get on this certification road and listing your products in the database. And this offer, it started last it started at the start of October. It's going for a year. And basically, it's a reduced price of AEF membership for the next 3 years. It's open to any company who hasn't belonged to the AEF before, so you can't be a current or past member. It's only open to, let's say, new companies. And the idea is that we hope that we can attract more companies to belong to the AEF, and we can increase the number of companies who are putting products in the database. Marco also mentioned before that we had a conformance test, and there are currently 5 licensed testing houses around the world that are authorized to run this conformance test. Some of the testing houses are being very successful and running a lot of tests for manufacturing companies. Some of the testing houses are slightly less successful and not running too many tests. So we wanted to make life slightly easier for them as well, and we're reducing the price of what we charge them annually to run the conformance test. Again, to make it easier for them to run the test and hopefully attract more companies to certify their products. Now, sort of coming back to the subject of interoperability and, you know, looking specifically at platform-to-platform connections and the problem the farmer faces today, is that we know that you know, farmers need to be able to have access to their data at all times. We know we need to make it easier for them to move their data from one place to another so that they can benefit from having that data and analyzing it. And so really we know that, you know, there is a need for this data communication between clouds to be standardized. And, you know, as mentioned, we've formed this AGIN project team, and we're starting down that road. With AGIN, we want to create this peer-to-peer network of participants who can be certified, can be trusted, and we have this kind of standardized contract, this standardized legal framework to make it easy to belong to the network and to make it easy for all our customers to share their data. So really we're trying to summarize all the AEF activities up into this big picture. You know, in the center of the picture we've got the farmer, and there are all the things that the farmer has to interact with, you know, on a day-to-day basis. Obviously, they've got to operate the machines, they've got to prepare prescription maps, send information to the machine, get information back from the machine. All that data has to be saved and, you know, if you like, sent to the government for some type of reporting. There's satellite information coming in, there could be drone information. It's all coming into the farmer. Around that, we have the blue circle of the AEF, and this is where we see our picture in this. Again, you know, focusing more on the machine, on the tractor and implement working in the field, but obviously there seems to be a need to grow outside just the tractor and implement scenario and look at other farm equipment as well, working in the field. But, you know, if we look at what we're doing today, we are working on tractor and implement combinations. We've got this TIM functionality released a couple of years ago. We're working on this wireless in-field communication, and we're working on the HSI piece, so high-speed communication along a common bus. And then, yes, you know, we're working on platform-to-platform communications as well. And we have a certification process, and that certification for Isobus products is recognized. You should recognize that with that wonderful sticker with the little blue squares on it. If we look towards the future, we kind of see that, you know, the future activities of the AEF, we should be focusing more on autonomous applications and mobile applications, and maybe we need to add irrigation communication in there as well. But we see that there's a future for the AEF because we have this strong collaboration of our member companies in this space, and people come together to volunteer their time to work on problems that we have collectively as an industry. And yeah, this is really the AEF's big picture. So hopefully this afternoon has been interesting. I hope we haven't gone on too long, and yeah, we really strongly hope that 2022 is a more normal year and we can all get together for more face-to-face activities, because again, all of the things we do, they rely on people coming together and cooperating, spending time together, such as the face-to-face Plugfest, and such as all our project teams actually coming face-to-face and working together. And we really hope that next year we kind of we can move forward in that way and move forward a bit faster. That's it. Are there any sort of questions or comments on anything you've seen this afternoon?
Looks like everybody knows.
Last one.
Then we need to free up the room for the next.
Just to clarify, I think I know the answer, but you have the Plugfest, but then you have also the alternative that keeps the Ethernet connection with the cloud and stuff that was operative in COVID times. That's still there, I suppose.
Yeah, that's correct. So the virtual Plugfest is still a possibility, and basically what Marco was working on this year and what he spoke about that took place in September, that was really to prove that it works. And now that we know that that technology works, we need to work out where it fits in. And we're kind of thinking or kind of imagining that we will still continue to have the two Plugfests face-to-face, but maybe we'll schedule a virtual Plugfest a third or a fourth time each year, again to give manufacturers the chance for that connection possibility. But it's a virtual Plugfest, they're a great tool, but they're not the replacement for that face-to-face experience. Okay. Any other questions, comments, concerns?
Everybody's tiring.
I know.
And leaving the room right now.
It's time to leave the show.
Yeah. By the way, I would like to thank you, Marco Brook, AEF Project Coordinator for the AEF and Conformance Test Project Coordinator, and Andrew Olive, Vice Chairman of the AEF. And thank you for being here. And we will take care also of new topics coming from our industry. Maybe. Thank you. Okay, and come visit us at booth A25, hall 36.
Hall 36. Yep.
Okay.
Thank you.
Have a good night.